friends, today we're going to talk about long division. Now, long division is not necessarily a concept that we cover in college algebra. However, it's an important skill to be able to do long division with numbers in order to do long division with polynomials. Probably has been a while since you've seen long division, so let's take a second and remind ourselves how it works. All right, now when I do long division, or when I teach long division, I like to write up the steps that we use. Division, multiplication, subtraction, and then bring it down. To represent that, I'll write a division symbol, a multiplication symbol, a subtraction symbol, and a downward arrow to remind me of those 4 steps I'm going to take each time I go through the process of long division. So let's look at an example, and I think you'll see how that process repeats over and over. So inside my division symbol, I'm going to write the number that I am dividing. For this example, we're going to make it 1,342. And then on the outside, I'll write the number I'm dividing by. For this example, I'm going to make it 3. So I am doing the division problem, 1,342 divided by 3. All right, so the first thing that we do is we look at the number on the inside and we do a division problem. Now, generally, you probably remember, we would start with that first digit of 1 and say, can 1 be divided by 3? No, it cannot, so then we are going to include the second digit. 13. Can 13 be divided by 3? Yes, it can. It divides 4 times. So I'll write the 4 directly above the 3. So I did the division part. Next, multiplication. We're going to multiply 4 by the 3 on the outside. 4 times 3 gives me 12. And I'll write that directly underneath the 13. All right, we did the multiplication part. Now let's do the subtraction. We are going to subtract 12 from 13. So I'll write that subtraction sign in front of the 12 and draw a line. 13 minus 12 is 1. So I'll write the 1 underneath the 12. And then our last step is bring down. So I will bring down the next digit, which is 4. And we're going to start the process over. 14 is my new number under the division sign. 14 divided by 3, also 4 times. 4 times 3 gives me 12. So I wrote the 4 up above the division bar, directly above the 4. 4 times 3 gave me 12, so I wrote the 12 underneath the 14. And then we're going to subtract. So I will subtract 12. 14 minus 12 is 2. And I'm going to draw the arrow to bring down that final digit of 2. I have 22 at the bottom here, and I'll start over again. 22 divided by 3, that's going to go 7 times. So 7 is written over the division bar, directly on top of the 2. 7 times 3 gives me 21, so I'll write 21 at the bottom underneath that 22. Last, we're going to subtract it. So 22 minus 21 gives me a remainder of 1. Okay, I don't have any more digits to bring down, so we need to interpret the answer that we have here. Now, at one point in your elementary school years, you might have written this answer as 447 and then using an R1 to indicate that you had a remainder of 1. That's accurate, but now that we're a little bit more advanced in our math, we're going to write it slightly differently. We're going to write it as a fraction. So instead of remainder 1, we're going to rewrite this. Let's see, I'll just pull it down to the bottom in a different color. So now we would write this as 447 and 1 divided by 3. 447 and 1/3. And the 1 comes from this remainder. The 3 comes from the number we are dividing by. Okay? Let's try one more just for practice. I want to encourage you to pause the video once I get the problem up and try it on your own before resuming the video and checking yourself. So I'm going to do 21,365 divided by 12. So 21,365 will go on the inside of the division symbol and 12 on the outside. So please go ahead and pause that video, work the problem yourself, and then come back and track it. All right, welcome back. So here we go. Remember, first is division. Can 2 be divided by 12? No. 21 divided by 12? Yes, it's going to go in 1 time. So I'll write a 1 above the 21. 1 times 12 is 12. So I'll write a 12 below the 21. We'll add our subtraction symbol and subtract 21 minus 12 to get 9. Bring down the next digit of 3, and we're looking at 93. Starting the process over with division. 93 divided by 12. Well, let's see. 7 times 12 gives me 84. That's going to be my closest match. So I'll write a 7 above the digit of 3. 7 times 12 is 84. I'll write 84 below 93. Add a subtraction symbol. And then we have 93 minus 84, giving me 9. Bringing down the next digit of 6. I'm looking at a 96 on the bottom. 96 divided by 12, well, that happens to go in evenly. It goes evenly 8 times. 8 times 12 is 96. So I'll write 96 below the other 96. Subtracting that, I'm left with 0. But we have one more digit to bring down, and that is a 5. We'll start the process over. 5 can't be divided by 12. So I would write a 0 above the digit of 5 to say 12 can't go into that number. And then we will have a remainder of 5. We could say 0 times 12 is 0. 5 minus 0 gives us a remainder of 5. We wouldn't have to do this part, but I want to let you see it so you see the whole thing complete. I would have a remainder of 5. And remember that at this point, we're going to write that as a fraction. So it would be, for a final answer, 1,780 and 5/12. 5 from the remainder, 12 from the number on the outside. Now, if this fraction of 5/12 could be reduced, we would want to reduce it before giving that as our final answer. In the next video, we'll talk about the same process except with polynomials. So once you're comfortable with this, move on to that video.